Hi, today we're going to take a function and using the difference quotient, we're going to estimate the slope of a tangent line at a point. So for today we're using the function 7.2x squared minus 6.4 and we're going to be finding the slope of the tangent line at 9. So this is going to be a little bit of a tedious process. We have to plug in a bunch of numbers, we have to use our calculator and evaluate. So here's how it looks. I've worked a little bit ahead here, but we're going to use our formula. So remember, this is the formula we're plugging into, our difference quotient. And so h is going to be 1 and always the x value is 9. So when we plug in, we're going to have f of x plus h. So that'd be x plus h would be 9 plus 1 minus f of x, remember x is 9, and then divide that by the h, which for this part is 1. So we're going to be finding f of 10 minus f of 9, and of course dividing that by 1. Now to find f of 10 and f of 9, we're going to take those values and we're going to plug them into our function. So f of 9 is when you take, well, let's start with f of 10. f of 10, we're going to take our 10 and we're going to put it into the function that was given everywhere for x. So it's going to look like this. 10 plugs in, and so f of 10 here, sorry it's a little dark, is going to be this much. Okay, and then f of 9 is then we're going to plug in 9, don't forget parentheses, into the function. So we're going to have 7.2 times 9 squared minus 6.4 times 9. And again, all that divided by 1, which, yeah, it's irrelevant. Okay, so working that out, so you pull out your calculator, you type in all that stuff, and so f of 10 is going to give you the value 656. So that's our f of 10. And then we're going to plug in all those numbers 9 into the function, and that's going to give us the value 525.6. So f of 10 minus f of 9 divided by 1, and we end up with 130.4. So this would be the estimate for our slope of the tangent line at 9. But we can do better. We can get a better estimate of the slope if we pick an h value that's closer to 0. So instead of 1 for h, we're going to choose 0.5 for h. So this next part, and again I've sort of already written in our numbers, we're going to be plugging in 0.5 for h. So the x is still 9, but 0.5 replaces the 1 in the previous example. So plugging that in here and running those numbers through, f of 9.5 minus f of 9 divided by the 0.5. Let's see, here's the numbers that we're going to get. We get 589. Now remember, we already did f of 9 earlier. We don't need to do that again. We just bring it on down and divide that by a half, or 0.5. So typing that in your calculator, for the h value of a half, we get a tangent line slope of this, 126.8. So that should be a better estimate of the slope of the tangent line at 9. Now again, if you want to get more accurate, you pick a smaller value for h, and so on. So the next three are picking smaller values for h. So we go to 0.1, we go to 0.01, we go to 0.001. And again, using our calculator, plugging them in. So for 0.1, if you plug in f of 9.1, subtract your f of 9, which we already did, and divide it by 0.1, we're going to end up with the value of 123.92. And again, we're using a calculator to do this. Same thing for the next one. Plug this guy in your calculator, you end up with a value of 123.272. Now practice with the calculator, because you know calculators are not easy and it's easy to make mistakes on them, so you've got to practice with that so that on a test or quiz or something in the future you're good with all those, so you don't make any mistakes with it. And the last value, when h is really small, we end up with a 123.2072. So every time we pick an h that smaller and smaller, what it looks like, these slope values that I'm getting just seem to be getting closer to 123. 123.2 maybe. If I really wanted to keep going and pick smaller and smaller h values, I could get even more accurate with this slope. So for right now, we have this estimate of the slope of our tangent line. Now, just concept-wise, let's see, what does this all mean here? So here's what we've done. What we did was we took our quotient, our difference quotient, and we basically let the h value get close to 0. So what we got was we got the approximate slope of our tangent line, which came out to that 123.2072. So when we used x is 9 and used our difference quotient and let h values get very small, this was our approximate value. So what that tells us is the slope of the tangent line at 9 is approximately 123.2072, which also can be called the derivative. So again, we want to get used to the slope of the tangent, and when we say derivative, and knowing that those are just interchangeable. So the derivative, again, is about 123.2072. Okay, so slope of the tangent line and the derivative at 9 are both the same, 123. Graphically, if you want an idea graphically, what is this? If you graph that function, that 7.2x squared, put it into Desmos, take a look at the picture, you're going to see something that looks like this parabola. And if you could put yourself a tangent line at that point, x is 9, and again, I'll just try to approximate this tangent line. I think it looks something like this. That slope of that tangent line, the slope right there at that point, would be about 123.2. Now, it doesn't look like it's that steep, but just remember the graph that I'm on is not got the normal scale. It's distorted a little bit. So again, that 123 is the slope of this green line, which is called a tangent line. All right, I hope this has been helpful.